On how to do basic processing on NMR data using MestReNova. The buttons and functions that we will be using are in the NMR group of functions, and they are activated upon opening of a data set. The first thing that needs to be done is the spectrum needs to be referenced. In other words, the x-axis that you can see here is an estimation by the instrument. We need to correct it for the exact value. So the first thing we need to do is zoom into this area between 7 and 8. And you can do that by choosing a zoom button or toggle Z on the keyboard. So I'm going to do to zoom in this area, and you want to zoom in much closer to a signal around 7.26. Okay, so this will be this guy here, and as you'll see, this one right now it's showing 727.03. Its exact value should be 726. Typically it's overestimated, so this one is also a good candidate as well as that. So I will be choosing actually the one in the middle, because I know that the peaks on the outside are corresponding to the compound, but not the reference signal. So now that I know which signal to choose, I'm going to press the reference button and point to that. So right now its value is very close. I could really leave it as is, but to standardize all spectra that we will be working on, we'll make it 726 even. So you can also associate a label with that value, deuterated chloroform, and when you hit OK, there will be a annotation saying that this is a internal reference peak. Okay, zooming out to the full spectrum can be done by pressing this button showing full spectrum, or F on the keyboard. Okay, now that the spectrum is is referenced, we need to do the second stage, which is getting to know the exact values of the peaks that are in the spectrum, and we do that by doing peak picking. And you'll notice that the biggest button right here is automated peak picking. Although this button is doing everything automatically, I strongly encourage you not to use it, and rather than that, use a manual threshold peak picking, because the algorithm is sometimes too liberal and picks every teeny tiny thing that's existing in the spectrum. So for example, these little impurities that exist here would be picked up, and we don't really want that. So manual threshold peak picking, or K on the keyboard, will set you in this mode. Actually, it would be much easier if I zoomed in a little bit closer to the area I will be working on. So manual threshold, and here the important part is you will be kind of drawing a rectangles. The tip of the peak needs to be inside the rectangle, otherwise it will not be read. So now we know it's 10.27 parts per million. Now I'm going to zoom out again and zoom in to this area, change to manual threshold peak picking, and with my mouse, with a mouse or a trackpad, you can change intensity, make them a little bit bigger, and I'm picking these two, actually 4 if you look closer. These, you don't have to do one at a time. You can create a larger rectangle to pick the peaks. Okay, I'm going to zoom out again and zoom into this region where we have the remaining signal. Again, K for manual threshold peak picking, and let's see what the value is. The utility of peak picking is that when you have the full spectrum, it's really difficult to guess the actual value just from the axis. you can read it up top, because sometimes the second or third place, decimal place, is important. Okay, now we have referenced and pick the peaks. Now the next area in this toolbar is multiple analysis. We will not be doing multiple analysis. This is beyond the scope of this course. However, so we're going to skip over multiple analysis and do integration. And just like in peak picking, integration can be done automatically. Although you got to know what you're doing, so I strongly suggest, now that we're learning how to use this program, to rely on manual integration. And it works in a similar way than peak picking. It has also a hotkey letter I. So what I will do, I'm going to zoom in again to our peak, and you want to actually go a bit closer this time. I'm going to switch to integration mode, and this tool calculates the area under the peak. So you want to start where there's a flat line, and you want to end where there's a flat line, as so. Okay. The very first integral you do will have a number 1.00 automatically associated to it, but we can change it later to reflect the number of hydrogens that are in the molecule. Okay, so quickly zoom out, zoom into what we call an aromatic region, switch to integration mode, and integrate it from flat to flat. Again, from flat to flat. You want to find this area between signals, if necessary, where the line goes closest to the baseline, and the baseline would be considered right here, that horizontal blue line. So I'm going to start my next integral here, stop here, and the last one is as so. All right. So we have relative integrations of 1 to 1 and a little bit, 1.09 and 1.4. Zooming out again and zooming into the peak at 2.7. A little bit closer, and again switching to integration mode and going from flat to flat. All right, so now this is complete. This is completely processed spectrum. Now we can move to the next stage, which will be building correlation table and assigning the structure of this unknown molecule. But at least we know what the chemical shifts are, we know what the multiplicities are, and we know what is the relative area under each peak. I know for a fact that this corresponds to a methyl group which has 3 hydrogens. So what I will do, I'm going to show you how to adjust the normalization of integrals. I'm going to switch to integration mode again, and when you hover over the line on the bottom and right click, you can have additional options and you can edit the integral. Here you know what the absolute area is, that is unchangeable, but you can normalize it to, we know it counts for 3 protons. I'm going to give it a value of 3. And as you can see, everything else is recalculated accordingly. And when I zoom out to the full spectrum, you'll notice that the values dropped across the board. Again, the actual values don't matter as much as the ratios between them, which we will be discussing another time. So now that you know how to do basic processing on the spectrum, the assignment that follows will have a raw data again for this time meta-tolualdehyde, and the area, the data you'll see will look like this. So what I want you to do is go through the steps of processing. You can reference the spectrum in one of 2 ways, either to this little guy, to chloroform 726, or you can also reference it to this one, which should be exactly 0. After referencing, pick all the peaks that are in the spectrum and integrate all the peaks that are present. Okay, so with that, that concludes the video.